The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast. The only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Gaprogman Taylor, and this is episode 25. Blazor, you want to run .NET where? This episode is a shortened version of a talk that I gave at Umbraco Festival 2018 on Blazor. It covers a little of the history of how we got from no CSS and JS to using HTML and CSS in our JS, all the way up to using .NET in the browser. Check out the show notes for a link to the full video version of the talk, which the Cogworks have graciously allowed me to use for the episode. So my thanks go to them for allowing me to use the audio for running the Umbraco Festival and allowing me to talk there. Just before we begin, did you know that the show has a mailing list and a Slack group? Why not sign up for the mailing list or join the Slack group by following the links in the show notes? Anyway, let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. Hello everyone! Can you hear me first off? Because I've got a bit of a sore throat today, so I apologise. Closer to the mic, right? How about now? Okay, so I'm Jamie Taylor. I do have a sore throat, so I may have to step off a bit and cough and then come back. I have been trying to clear the sore throat all week, but it's just not wanting to move. It will be tomorrow morning. I'll wake up and I will have it won't be hurting at all, but I've got all sorts of meds with me today to try and help that. So today I thought I'd talk to you a bit about Blazor, which is a new Microsoft technology. You'll see later that it isn't even vaguely new, but there you go. So the first part, so this is going to be divided into two parts. I'm going to really quickly go through a little bit of HTML and JavaScript and CSS, how we got to where we are, and then I'm going to talk about Blazor, and I'm going to show off two demos. One is hopefully related, so it's not just going to be completely boring. I am at .NET Core blog on Twitter, and I run the .NET Core podcast, which is the t-shirt I'm wearing. Oh yes! So if anybody wants to talk .NET Core, ASP.NET Core, EF Core, Signal, or anything like that, come and have a chat with me. I'd love to, interview you for the podcast, talk to you on the podcast. That'd be fantastic. Hopefully the first bit won't take too long. I'm going to really quickly breeze through it. All of the slides are all already on GitHub because it uses Markdown and Reveal.js. I'll send the link around on Twitter later on, so definitely pull the code down and have a look. And when you're looking through them, hit S on your keyboard because you get these really cool slide notes. I've put loads of stuff in. Each slide has a bunch of notes already, so that's mainly a prompt for me, but it's also a little bit on there. So if you can figure out what in which Doris gets her oats is from, without using Google, you can get a .NET Core sticker from me, or just come up to me and say, I want a sticker, and I'll give you a sticker. I don't really know. Just really quick little bit about me. I'm a .NET Core maniac. That's how I've been described. I am a serial podcast creator. I've got .NET Core podcast, Waffling Tailors, which is me and my brother talking about video games, and Dev Otaku, which is me and a few of my friends talking about relaxing finding ways to relax and disconnect from the tech industry. But that's not what I'm talking about today. Hopefully this is going to be really quick. When HTML started, everything was static and it was all good. In fact, if you Google for it, the Space Jam website is still live and it is all HTML tables. The entire site is HTML. There is some JavaScript on there now, which is Google Tag Manager, which is how they know they need to make a sequel, because everybody keeps hitting the website and they go, wow, people in their 20s to 40s want a Space Jam sequel. So well done, everyone, we're getting a Space Jam sequel. If you have never seen Space Jam, don't. Back in 1994, we were essentially told there was going to be no styling other than inline styling. And I've got this directly from, check the show notes and stuff and check the links and that. We were essentially told, sorry, you're on your own. It's like tech. There's nothing other than inline styling. And then less than a year later, there was a W3C group all about creating style sheets and cascading them. So, the idea that this technology is constantly changing, constantly in flux. And then just a little bit of history. At the same time that was going on, Dolly the Sheep was being cloned. Internet Explorer 3 supported CSS before it was released, so well done, I guess. And then CSS Level 1 was ratified in 97. We can't blame Brandon Ike because JavaScript came along and it was not a number. He was tasked with creating a server-side, almost like a scripting language, and he was fighting against Perl and other people, and he was given 10 days to come up with the basic version of it, and he released it, and then all the other browsers went, that's fantastic, why don't we not implement that and implement our own version? Which is why it's why we have all the different browsers all used to have different support for different things, why we ended up with different versions of the standard. And back in the day, in the late 90s, early 2000s, if you inspected pages, it was, we still have them now. If IE less than 9, load this JavaScript in to be able to display the page. And why in the late 90s, we always had the little badges in, usually the bottom right-hand corner. This website works best with IE 7, or this website works best with Netscape, stuff like that. Then along came the ECMA standard, and nothing changed. Version 4 was abandoned for a bunch of political reasons. And then we had more ECMA standards. There's too many standard versions, and then at least you know where the naming standard comes from. It's not even related. ES6 is ES2 2015, because why not? Let's do version numbers. And then came jQuery, and we all went, fantastic, finally, a system that allows us to run any kind of JavaScript on any kind of browser. That's brilliant, except the first version of it was 90 kilobytes. And you're thinking, that's not a lot. Well, version 3, the current LTS version, is 86 kilobytes. If you want to use AMP, you've got a 50 kilobyte JavaScript limit. You can't include jQuery, so you've got to ditch all of that. Maybe you can compile your own version and just include the stuff you want, but even so. And then along came the UI frameworks. All of them required jQuery to work. So we've got this huge dependency now. We've got this monkey patching system. What's going on? I can't deal with this. There's too many things. And then Node.js on a satellite, because that makes sense. Can you imagine a satellite crashes into your house and the developer goes, sorry, I didn't do a check for not a number, and then that's why your house has been trashed. Then we wanted type safety, so we've got transpiler, so you can write something in a different language and compile it into Java. Obviously the last two are joke ones. Arnold.js is all Arnie quotes, and Trump.js is making JavaScript great again. But the first three are real transpilers. You can write stuff in CoffeeScript, and it will be type safety-ish, and then you compile it down to JavaScript, and there's lots of extra code. But the problem is all this extra code just to do the basic stuff, right? And then we get single-page applications, and we've got so much of this stuff loaded into the browser, and it's just getting a bit crazy. So spas are brilliant, except to be able to load the page, you've got to download all of this JavaScript. And if you've done it wrong, like some people I know, maybe I work with them, maybe I don't, I can't actually say whether I do or not, you end up with a spa that has 20 megabytes of JavaScript just to load the login page. And then if you can't log in, you've wasted all of that time loading the stuff, right? And that's all minified and uglified as well, so that's no good. And then in 2010, Chris Donnell goes, why can't we just have .NET in the browser? That'd be fantastic, wouldn't it? So he started this project, .NET Anywhere, and the idea was to cross-compile the .NET framework in its C and C++ code over to WebAssembly, which was just sort of being ratified and thought about. So WebAssembly, I'll come on to it in a minute, is a way of running binaries in the browser, which is genius. Obviously, there's going to be security holes, because there always are, but the idea is that it's a walled garden sort of JavaScript-y runtime, but then JavaScript has a bunch of stuff where you can go, I'll get the GPS location, I'll take payments. So the problem with this was that you have to download the entirety of .NET Framework to be able to run your app in the browser. So that took a while. So then along came Steve Sanderson, who went, hey, I've done this thing called Knockout.js, and it's fantastic. And I've heard about this thing called .NET Anywhere. There might be something in it. Maybe I can take the knowledge I know about making a JavaScript framework and make this a little better. Plus, I kind of work for Microsoft anyway, so maybe I can do something there. Xamarin got bought by Microsoft. Along with Xamarin came Mono. There's a huge history of how Microsoft bought Mono and the deal that they got, and it's a bit crazy, really. But essentially, .NET Framework has always been a thin wrapper around the Windows 32 programming API. Mono didn't have that because it was explicitly designed to run on Unix systems. So Mono has everything that you need, from the high-level stuff that we write as .NET developers all the way down to the low-level C code and assembly to actually make those things happen. So they went, why don't we cross-compile that into WebAssembly? We've got a tiny .NET environment that's already doesn't need the Windows 32 APIs. So my mate Paul Sale, who's giving a talk out there, we were both at Hack 24 on the same weekend that WebAssembly was officially announced. We were busy losing at Hack 24. I'm not bitter about it at all. But WebAssembly allows you to have a sandbox similar to like a JavaScript runtime, and you just throw a pre-compiled binary at it. This compiled binary can be from C code, from Dart, from Go, from C#, whatever you want, and it will run at native speed in the browser, which is fantastic. The only drawback is you've got to download the binary, which can take a while, and you can't really compress them because it's already compiled. So what is Blazor? So imagine you can do UI stuff without having to use JavaScript. I know, right? This has been a promise we've been given for decades, UI without the JavaScript. But that's entirely what it is. So imagine you could do that. Imagine that you've got .NET in your browser. Imagine being able to do stuff on the server and the data being sent across to the client. So the client doesn't actually have to do anything. You can just, here's the view, just show this view. It's not a problem. And that's what Blazor is. It's also a combination of browser and Razor, because it's this idea of running the actual Razor in the browser. And then there was an ASP.NET Core community stand-up showing off the public preview. If you don't watch the ASP.NET community stand-ups and you're interested in .NET, ASP.NET, regardless of whether it's Framework or Core or Mono or Xamarin, you should definitely watch it. It's live.asp.net. They're vaguely every week on a Tuesday. Usually it's really late at night, but it's totally worth watching because you get to learn all of the new stuff that's coming out if you're not an MVP. It's Scott Hansen and John Galloway and Damien Edwards sit around a table and discuss, hey, so the next version of .NET is going to have this, and this is how it works, and they go into loads of detail. They also make fun of each other for the different microphones they use. So NDC Oslo 2017, the bomb was dropped. I say the bomb, obviously it's not really a bomb. Steve Sanderson, that's a link there, you can click it and go watch it. Again, pull down the slides and go have a look. But essentially it's an hour and 20 minutes of Steve Sanderson going, wouldn't it be great if we could do .NET in the browser? And he blows everyone away with this, hey, look, here's this app that's running in the browser. If you haven't seen that talk and you have an hour and 20 minutes spare, most of you guys will have traveled down on a train, watch it. It is amazing because he does a much better job of describing Blazor than I do. But this was absolutely huge. .NET in the browser, that's mad. You can't get compiled binaries in the browser. Well, yes, you can. And it's the full .NET stack as well. It's not just this API and that API. It's the whole thing. The complete shebang. Everything you might want. But how does it work, right? I'm talking about how this Blazor thing is brilliant, but I haven't actually discussed how it works yet. Well, what happens is, obviously, your browser downloads the HTML. HTML includes a tiny JavaScript file, which bootstraps another JavaScript file, which pulls down mono.js. So mono.js pulls down the Mono WebAssembly. So this is a compiled version of Mono for WebAssembly. It then passes that to the browser. It then does some shim stuff in case you're on a Microsoft browser because they don't quite fully support WebAssembly. I mean, they do. Edge does, but IE doesn't. And it does some stuff where it loads in the Mono runtime and sets up an entire runtime ready for your app. It then goes, right, give me the app DLL. And for those of you who don't know how the GAC works, the Global Assembly Cache, when you start your app, .NET or Mono or whatever will look in the local directory for whatever DLLs it needs and for the versions that it needs. If it doesn't find them, it'll go globally. And if it doesn't find them, it'll go universally. It'll look at in a wider path. So what the Mono runtime does is it goes, hey, I need system.link. Hey, I need newtonsoft.json. Hey, I need this. Hey, I need this. And it'll pull it from your server. So you can supply the very specific version of that DLL in the same way that you would ship the very specific DLL with your websites, with your desktop apps. And then it will boot that app, and then it'll start creating a virtual DOM in the same way that like React and Angular do. And it will create a render tree, and every time something changes, it doesn't do a full page refresh. It just goes, hey, this is that one component here that's changed. Send it through to the browser. The browser then will then just change that one component, which saves on memory usage. It saves all sorts of stuff. Again, it's an Angular thing, Angular and React thing, so it's not new. But the problem is that the DLLs are huge. I don't know whether you can see it there, but newtonsoft.json adds over 16 megabytes of DLLs. And that's ridiculous, right? You don't want to do that. Before the 2.1 preview, there was no such thing as IL shaking. In 2.1 onwards, we now have IL shaking for Blazor, which is fantastic. It's kind of like tree shaking. It's the same kind of idea. Also, don't include 15 megabytes of .NET packages because that's just ridiculous. Essentially, IL shaking, for those of you who don't know, what happens is the jitter, the compiler comes along and goes, you're not using those methods and types, so I'm going to recompile Newtonsoft.json and just not include those things. So then you get a smaller binary which just has deserialized object of type T, which is fantastic. And then that also means if it wants to, it can optimize that code if it hasn't already been optimized. Because that's one of the things that .NET Core 2.2, I think, can do. It's all CSHTML, so you're downloading the Razor files into the browser, except the Razor files are all compiled into DLLs. I'll come into that in a minute. So with ASP.NET and ASP.NET Core, when you're in debug mode, you can make a change to the CSHTML, hit save, refresh, and your change is there. Fantastic. Blazor, that doesn't work because you make a change, you save it, you need to recompile the entire app because you're sending DLLs down to the browser. You're not sending the HTML. So it all gets a bit wobbly. But it's essentially these three things, right? You've got components, which is very similar to Angular or React components. It's stuff that looks like HTML but isn't, which is really cool. Each component can have a number of parameters or a number of things that are injectable, and each component can have as many child items as you want. Obviously, the more you include, you get past a 20 or 30 limit, it will start slowing down the page render time because it takes time to re-render. And like I say, it's along the same lines as Angular and React, but it's in .NET, so it's a lot more familiar to some of us who are more back-end focused. And because it's not Angular or React, it's really fast, but it's a little big. During one of the ASP.NET community stand-ups, they take live questions from the audience. So if you're watching on YouTube, I watch it on my phone, but if you're watching on your computer, your tablet, whatever, and you're watching along live, you can actually post a question into the chat, and someone on the video feed will read out the question and answer it for you. But yeah, at about 22 minutes, 47 seconds into one of the ASP.NET community stand-ups, I asked a question, and that is, hey, these components look a little bit like Razor pages. Are they the same? So the way that it works is in Razor pages is just CS HTML. It gets a little bit of pre-rendering done to it to create HTML and sends it down, but with Blazor components, it gets converted into a class and then packaged into a DLL and sent down to your browser. So that means that obviously it's no longer markup in the same sense. So the Blazor runtime gets all of these DLLs, and you say, hey, give me this page. And the Blazor runtime goes into these DLLs and goes, right, I need to render this component here and that component there, and it builds a fake rendered tree inside of your browser in memory space. And then it takes that rendered tree and then puts that on the screen. If you have multiple tabs on screen, you click the second tab. Instead of having to redraw the entire tab, it just goes, right, I will just swap that component out for this component. And it just swaps things around. So you've got a single page application without the crazy routing and the hash bang and all that kind of stuff. So there's two types, and I'll come on to that in a minute, but you can have server-side rendering where everything's done entirely on the server, and the server goes, just update those 5 pixels for me. And the browser just sits there as a completely dumb terminal and goes, okay, it just shows you a pie chart or shows you an image. I don't have any server-side specific demos, but they're not that difficult to make. So rendering, it creates a virtual DOM or a render tree, and then inserts all of those components into that, generates the HTML from those components, and then displays it on screen. So this is client-side only, but you have server-side as well. I kind of hinted at that. So there's the two versions. So on the left-hand side of this image, so this is client-side rendering. You've got the server, which is a wonderful image. And you've got, say, Chrome. Client-side rendering is everything is shifted to the client, and the Blazor runtime fires, and all of the things get loaded, and everything happens in the browser. Whereas server-side rendering, what happens is, your client says to the server, can I have the page? The server goes, here's a tiny bit of HTML, a tiny bit of JavaScript, a tiny bit of CS. The JavaScript sets up a signaler connection back to the server. All of the Blazor stuff is done server-side, and you've got this real-time bidirectional communication between the browser and the server, such that you could have maybe an analytics dashboard that it lives entirely on the server, and as these messages come through and you need to update your charts, a bit like the Azure dashboard, but the Azure dashboard doesn't use Blazor, but imagine the Azure dashboard with all your pie charts and your bar graphs and all that kind of thing showing how your apps are living. Imagine you had that, but all the data was being piped in real time down to the browser. Because all that needs to happen is the server goes, oh, brilliant, I could run this at full time, change these charts, and just send down the pixels that need to change. And that's all that happens. Blazor is really good at single-page applications. If you need to just throw up a thing and have somebody interact with it and get the data back, it's really good for that. Not so good for multi-page applications because it gets a bit wobbly and you have to map everything, but it's really good. If you already have an API, it's fantastic for adding a front end to that. It's really good for agile stuff. So if you need to build something really rapidly, Blazor is fantastic. Rather than having to pull down 5 million NPM packages and then deal with, well, this one's not been updated, that one's not been updated, I now have a vulnerability over here. Blazor doesn't have that because it's .NET. There are vulnerabilities in .NET, but they get fixed very quickly. I am actually attempting to build an entire blogging engine out of it using Markdown. So one of my blogs is entirely in Markdown. I'm just trying to build a separate front end for that to see how fast it is. So I've got a blog that's WordPress and one that's Ghost. So that's a JS front end. I'm just trying to see whether WordPress, Ghost, and Blazor, which one's fastest, which one's more secure. There's also Bletris. Now this isn't one that I've written, which is Blazor Tetris. This one was announced a couple of weeks back. I couldn't get this to work on my browser when I was trying this the other day, but essentially you've got Tetris being played in the browser. That's all C# code that's running there. That's pretty cool. You could do whatever you can even do video games, whatever you want to. So there are a few pitfalls with Blazor, and I've mentioned a few already. These are things like if you change the view, you need to recompile the entire app because it gets compiled into your DLLs. Your .NET code is running inside of WebAssembly, which is running inside of JavaScript. So when it throws an exception, you've got 15 layers before it hits you. So you get these wonderful stack traces that have 5 million lines in them that are all minified. And then you finally get to, oh, right, I got a null ref, but I've got 25,000 lines of exceptions. And then it gets to me, which is a bit mad. It has experimental client-side debugging. Oh, yeah, and when these exceptions are thrown, your app continues running. It's not like C# where an exception happens and the whole thing stops. Your app keeps running because, well, I've already thrown that exception and I'm still sort of operating, which is a bit weird. What's great about Blazor is I have a shared DLL here with one model in it, and it is my data model. This is a DLL that I can run on a desktop app. I can run in ASP.NET Framework. I can run in .NET Core. I can Mono, Xamarin, whatever I want, right? This is one DLL, and I don't have to do any more TypeScript, JavaScript to C# mappings or anything, because this DLL here is actually referenced in my page that I loaded, Fetch Timeline. I've actually got an actual use of that DLL. So I'm pulling the DLL through. So I no longer have to keep all of my view models and my data models in sync because it's the same model. So we've got a project where you give it a bunch of C# models to be able to produce the TypeScript models. The problem is you've got to remember to keep running that script to keep them up to date. Maybe you can do it on a build or something, but you've got to remember to do that. Whereas this, it's the actual model. So if I scroll down here, I'm actually saying, go get me an array of these items, which is fantastic because I don't have to do anything special. It's not the best code ever because I threw it together like 2 or 3 days ago. So again, I'm passing in that parameter, this POCO, I'm passing all the way down, but it's C# and it's running in the browser, right? So the one thing I don't like about this is in Umbraco I've got that text field, which is a markdown field. It renders it on the headless Umbraco end and then sends me the HTML down the pipes. If I go back to this view, where's my view over here, where I typed in a couple of hashes and a bullet point there, that gets converted to HTML and then sent down the pipe. If I don't do markup string, it literally just puts the string there, so I'll get H3 and then the text and then a hyphen. So I've had to pull in ASP.NET Core into this view to be able to do that. If I can figure out a way of doing that without using markup string or HTML raw, this page will load infinitely faster because it's not having to include ASP.NET Core. But because it's doing IL shaking, I'm saying include ASP.NET Core, but actually it'll only include the methods required to expose that API. So there's this tiny thing that's running in my browser. So I've got a model I'm passing to Umbraco, a model I'm consuming on the server, and a model I'm using in the client, and they're all exactly the same. I don't need to say to Umbraco, oh, hey, I'll do a DTO to your format, and then a DTO back to my format, then another DTO over to the client. It is literally just, here's your C# class I'm just passing around, which is mad. There's loads of documentation and examples on Blazor out there in the wild. There's the official docs, which is blazor.net. Ed Charbonneau, Progress Telework, does a weekly Twitch stream where he's building some apps in Blazor on Blazor Status Changed. I had Ed on episode 5 of the podcast. So I'll say any questions. It says here it's been 42 minutes, but nobody's come in to tell me to shut up. So if you have any questions, I can attempt to answer them.
What are the security implications of loading these DLLs in the browser?
Right, yeah, so that's a really important question. So the question was, what is the security implication of loading a random DLL into the browser? Well, what's the security implication of loading a random NPM package into the browser? It's the same sort of thing, right? Except you've got similar sort of lockdown, runtime, walled garden area. So you have the same idea. Okay, so how many of us use Newtonsoft JSON? How many? Keep your hand up if you've looked into the source code. You're loading this random DLL in. You're assuming it's good because it's part of the .NET standard as well. So you assume it's good. Yeah, you're right. Loading a random DLL into the browser can be dangerous. Again, it's up to you to sort of vet that in the same way that there was the talk this morning about the security stuff. You kind of need to vet the code that you're going to run anyway. Yep. Okay, so it's essentially, if you can run WebAssembly, you can run Blazor. So if you search on can I use for WebAssembly, you can see that the browser support essentially for WebAssembly is the same as
.NET.
No dependency on .NET, because as long as you can run WebAssembly, then you can load the version of Mono that's compiled for it. So as long as it's one of those green browsers along there, i.e. nothing made by Microsoft. Well, I mean, Edge works, but works. But as long as it's one of those green browsers there, then it'll work. So there is a shim available for IE 11, I believe. I think that's all I've really got to say about Blazor. But yeah, if you do have any other questions, I could totally answer them. If you want to talk .NET Core, I could talk .NET Core. If you want to be on the podcast, let me know as well. If you want a sticker, let me know. If you figured out what part 1 in which Doris gets her oats is, come and let me know, and I'll give you a sticker, or just let me know, and you don't have to have a sticker. Thank you all so much. This episode was an edited version of the talk that I gave at Umbraco Festival 2018 on Blazor. Check out the show notes for a link to the full video version of the talk, which the Cogworks have graciously allowed me to use for the episode. So my thanks go to them for allowing me to use the audio, and for running the Umbraco Festival and allowing me to talk there. Remember to check the show notes for a link to the full transcription of this episode, which is available at .netcore.show. Also, don't forget to join the mailing list or the Slack group for the show. Check the show notes for links to those. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks.